Today we're going to talk about factoring strategies. The first one is the first strategy you should always look for, and that is finding the greatest common factor. So here we have a very nice binomial. That means two terms. Each of the terms have 7, a factor of 7, and a factor of x in common. So we could factor out 7x. That would leave us x plus 2. Okay, I want you to see this second expression the same way, that it is two terms, right, separated by an addition sign, and those two terms have things in common. They each have a factor of 7, and they each have a factor of x minus 2. So we can factor out a 7, a factor of x minus 2. And I'm going to use a big bracket, although you don't have to see what's left. So if I factor out 7 and a single factor of x minus 2, I'm left with one factor of x minus 2. If I factor out a 7 and a factor of x minus 2, I'm left with a 2. So what I have here is 7, x minus 2, and what's in my bracket? Well, it's x minus 2 plus 2, so just x. Okay, so if you want to be really, I don't know, algebraic about it, you might write it as 7x, x minus 2. That saves me from foiling this thing out, distributing the 7, distributing the 14, collecting like terms, and then factoring only to find that it is 7x times x minus 2. How about difference of two squares? Well, we have an easy version and an amped up version. So difference of two squares, which I think most students like. This would be x minus 7 times x plus 7. And here it's just everything in here is a square. 9's a square, 16 is a square, x to the 4th is a square, 49 is a square, 121 is a square, y squared is a square. So we could factor this into, let's see, 3/4 x squared, 3/4 x squared, 7/11 y, 7/11 y minus plus. Done. Sums or differences of cubes. I think a lot of students forget about sums or difference of cubes, and they just want to say that x cubed plus y cubed is just x plus y quantity cubed. Oops. Well, my pen refused to even write that, so let me get that out of here. Okay. X cubed plus y cubed actually factors into x plus y times the quantity x squared minus xy plus y squared. And I'm going to prove that to you by multiplying this out. So I'm going to multiply x times each term, and I'm going to multiply y times each term. So I'm going to get x times x squared, so x cubed, minus x squared y plus xy squared. That's multiplying x all the way across. Plus, and I'm going to write this in alphabetical order, x squared y minus xy squared plus y cubed. And if we look at this, my x squared y term, I have a negative x squared y term and a positive x squared y term. I have a positive xy squared term and a negative xy squared term. And so all I'm left with is x cubed plus y cubed. So indeed, x cubed plus y cubed factors into x plus y times the quantity x squared minus xy plus y squared. It is also true that the difference of two cubes factors in a similar fashion. It's x minus y times the quantity x squared plus xy plus y squared. And some people, I will, I will say this, remember the way the signs go using the word soap. This is the same, this is the opposite, and this is always positive. This is the same, this is the opposite, and this is always positive. So some people like to remember how the signs go using soap. So let's try a few. X cubed minus 125. Well, x cubed is a cube and 125 is a cube. If you want to put your signs in first, it'll be minus, plus, plus. This will be the cube root, that's x, and the cube root, that's 5. This will be the square of the first term, x squared. This will be the product of x and 5, 5x, and this will be the square of the last term, 25. Let's try that again. 27 is a cube, x is a cube, and 8 is a cube. The signs will go positive, negative, positive. The cube root of this is 3x. The cube root of 8 is 2. Here it's going to be the square of the first term, so 9x squared. 2 times 3x, which would be 6x, and 2 squared, 4. And that's how I factor cubes. And now we get trinomials, which will factor into 2 binomials. We'd like them all to. Some of them do, some of them don't. And some people like the guess and check strategy, where you try, 4x and x, or 2x and 2x, and then there's 5 and 3, or 3 and 5, or 15 and 1, 1 and 15. Some people are really good at the guess and check strategy. If you're really good at the guess and check strategy, go for it. Use guess and check. If you're not good at the guess and check strategy, I'm going to suggest perhaps doing it by grouping. But first we have to create a 4-term polynomial. So we're going to do that by multiplying 4 times negative 15, which would be negative 60. And now we're going to look at factors of negative 60 to see if any of them add up to 4. Okay, so I want it to be a positive 4. So as I list my factors of negative 60, I'm going to make the smaller one negative and the bigger one positive, because I'm looking for something that totals up to this 4. So negative 1 times 60, well, if I add those together, I'm going to get 59, so that's not going to work. Negative 2 times 30, that's going to add up to 28. That's not going to work. Negative 3 times 20, that's 17. Negative 4 times 15, that's 11. Negative 5 times 12, that's 7. Getting closer. Negative 6 times 10. Negative 6 plus 10 is 4, so that's going to work. So I'm going to rewrite 4x as negative 6x plus 10x. So my first term, 4x squared, is going to stay. Minus 6x plus 10x. Okay, so that's going to total 4x if I added them together, but I want them separate. Minus 15. Now what I've created is 4 terms, which I'm going to factor by grouping. So 4x squared and 6x have 2x in common, leaving 2x minus 3. 10x and 15 have 5 in common, leaving 2x minus 3. Now what I've done is I've created from 4 terms to 2 terms, and those 2 terms have 2x minus 3 in common. So 2x minus 3, and if I factor it from the first term, I have 2x, and if I factor it from the second term, I have plus 5. So this is 2x minus 3 times 2x plus 5. If you like that, great. Let's show that one more time. There would be a lot of guess and check in this. So 18 times 10 is 180. So I need factors of 180 that add up to negative 27. It is a positive 180, and we're trying to get a negative 27, so both of the factors will be negative. So -1 and -180. That's way too big. -2 and -90, still -92. -3 and -60. No, no, no. Let's jump ahead. Maybe -10 and -18. That's -28. That's still a little too big. 11 won't go. How about -12 and -1? Let's see, 15. Hey, that's -27 when I add them together. So I'm going to put an x here and an x here. So I have 18x squared minus 12x minus 15x plus 10. And I am going to factor this now by grouping. So the -18x squared stayed and the 10 stayed, but the -27 was rewritten as -12x minus 15x. Okay, so these terms have 6x in common, leaving 3x minus 2. These terms have 5 in common, but if I just factor out the 5, I'm going to have -3x plus 2, and I want it to be positive 3x minus 2. So I am also going to factor out a negative. So if I factor out the negative, this is going to become 3x. And if I factor a negative away from a positive number, it becomes a negative number. So now I've got two terms. They have 3x minus 2 in common, leaving 6x minus 5. So this is 3x minus 2 times 6x minus 5. So here's the reason why in elementary school you made tables of factors, because it helps to create a grouping strategy for factoring. By the way, if you have trouble making factors, you can use your calculator. In y equals, just type 180, right? That was the number we were looking for, divided by x, and then go to your table. See, here are my factor pairs, 1 and 180, 2 and 90, 3 and 60, 4 and 45, 5 and 36, 6 and 30, 7, nothing, well, 7 and something, 8 and 12.5, 9 and 20, 10 and 18, 11 and something long, 12 and 15. There's 12 and 15, and if I remembered that I needed them both to be negative, I would have gotten it. So feel free to use your calculator as well.